Okay, starting question 5 of homework 5 here on radians, and I start with the formula booklet. And this is the formula booklet under trigonometric identities. There towards the bottom we have small angle approximations, so they are given to you, so there's no excuse to not know what they are. Sine theta and tan theta both are approximately equal to theta when it's small. Cos theta is the tricky one, and that's 1 minus theta squared over 2. That's the one we're going to need for this question. So at the side of the page here, I'm just going to copy that in. 1 minus theta squared over 2, like that, for cos theta. And now I'm going to apply that to the expression we've been given to work on, which is this 1 plus cos theta minus 3 cos squared theta. We're trying to show that it's approximately equal to that. Let's just do it one line at a time. So cos theta here, just copy in the 1 minus theta squared over 2. Then minus 3, lots of cos squared theta, and of course cos squared theta really is cos theta all squared. So that squared there is that squared there. Cos theta is going to go inside the bracket as 1 minus theta squared over 2. Okay, now we've just got to tidy up a little bit, expand the brackets and so on. Okay, here temptation is to multiply 3 by the minus 3, but of course we've got the squaring to do first. So first thing to do then is to expand this bracket squared, and if it helps, quite often it helps, by the way, to write the bracket twice if necessary, just at the side of the page like that, so you don't make a mistake. So 1 times 1 is 1, you've got a minus theta squared over 2 there, you've got another minus theta squared over 2, and then finally you've got a plus theta to the power of 4. It's all over 4. Okay, next line down we're going to be able to then multiply 3 by that 3. Okay, we've got 1 plus 1 is 2, minus the theta squared over 2. Right, minus 3 times 1, minus 3 times minus theta squared over 2, so plus 3 theta squared over 2, and that happens again. And then finally minus 3 times that positive, so it's minus 3 theta to the 4 over 4. Okay, a little bit of tidying up to do now. We've got 2 minus 3 is minus 1. Okay, we've got effectively minus a half theta squared plus 3 halves plus another 3 halves. Okay, well 3 halves plus 3 halves is 3. Take away a half is 2.5 or 5 over 2. So that's minus a half plus 3 halves plus 3 halves. You can do it on a calculator if you need to, and you'll see that it's that it's plus 5 over 2. Lots of theta squared. And then over here we've got minus 3/4 theta to the 4. Okay, compare that to what we're aiming for. We're aiming for minus 1 plus 5 over 2 theta squared. Stop. Well, we've got the first two terms, but we've also got this last term here as well. Well, what's happened to that? Well, we've got to remember that theta is small. That's the whole premise of this question, is that theta is small. Now, if theta is really small, something like 0.1, 0.1 to the power of 4 would be like 0.0001. So then that then is so small it's negligible. Okay, so theta to the 4 is negligible, so it's ignored. Therefore we can confirm that the original expression is indeed roughly equal to the minus 1 plus 5 over 2 theta squared, QED. Okay, that sentence there, or something similar to that, to indicate that y theta to the 4 just drops out, basically because it's so small it can be ignored. That's important. Okay.